Welcome to Cloudy ML. It's Vikas here, and today we are going to talk about a problem that was asked to me personally during an interview with Royal Bank of Canada during a data analyst interview. And it was a simple problem, and it was regarding adding two numbers. So first they asked me like, okay, just please add two numbers. So that's what I did, which they told me to do. Oops, sorry. And when we think of addition, it's like, okay, define x, y, z equals to x plus y. And yeah, I tried to return z and just printed add, okay, let's say 2 3. I gave them the answer, it was correct. And during the second part they told me that mind boggled me, and I led to the confusion and thought that, okay, is this even possible? So what they told me during the second part is that, okay, you've added two numbers, you did a good job. Okay, now add two numbers without using a plus operator. Okay, then I thought that this one operator here, this is the soul of this whole function. And is it even possible to solve this question without this operator? Unfortunately, I wasn't able to, answer that question in the interview, but the interviewer was, kind enough to explain me the process, as I was curious to know that, okay, how is this possible? So she told me that, okay, when you define add xy, now I know this will be a lot to take, and there are like many things which will confuse you, but I'll just explain you the whole. This is a small program, but this is very complicated to take and just fit into the mind. So I'm just going to explain you the whole situation. So this was the whole program that, okay, define add xy y while y not equals to 0. This was the another condition. You have to carry equals to x and operation y. Then you have to put x equals to x XOR y. People don't know, like, this is an XOR operation. Let me comment this one then. Then I was told that, okay, after that, if you do this magical operation, this one, and then return x, you will be surprised to know that this actually performs the operation of addition. Let's try this again. Print 2 3, and it's gonna magically give you the answer. So I was like, okay, what happened here? So I'll just show you the explanation of this one. That, okay, define add xy. So this was the definition of the function. And after this was the condition, that while y not equals to 0, because this is the condition, because if y equals to 0, as we all know, x plus y equals to x, right? Pretty simple. So what happened after this step? Okay, so carry. Now carry will be the additional variable that we created, and it's gonna perform x and Why? So as we all know, it is a bitwise operator, and there's a special condition which we all know. Let me open up my notes. As we all know, the AND gate has this special condition that if both the gates are 1, then only you get the result to 1. So this was the condition. And let's say it's 2 and 3, right? So binary of 2 is 1, 2, 3, 4, 5, 6, 7, 8. So this will be binary for 2, right? And 1, 2, 3, 4, 5, 6, 7, 8. This will be the binary for 3. I'll just make this clear so that there's no confusion. And if we perform the AND operation on these two numbers, so 0 and 0, it will be 0, 0 and 0, 0. This is all easy. So 1 and 1 will be 1, and 0 and 1 will be 0. So this, we got the result as 2, right? So this is our carry. Please remember this one. Currently the carry is 2, right? So I'll just put the comment here that carry equals 2. Remember this one. Now X and Y with a XOR operation, right? Now XOR operation was designed which like exclusive OR, so that both the conditions, when they are 1, the condition gives you the 0, right? So this was the XOR gate, like 0 0 0 0 1 1 1 0 1, and if both the conditions are true, it gives you 0, right? So let's perform the operation again. So this is on X and Y. So like 1 2 3 4 5 6 7 8, and this is the binary for 2. 1 2 3 4 5 6 7 8. So the binary for 3. Oops, sorry. 2 3. And if we perform the XOR operation here, so 0 0 0 0 0 0, and 1 is again 0, and 0 and 1 is 1, right? So now the result is 1, and this is our X. So we have to remember this one as well. Now after this one, X equals to 1, right? Now this is a special operator which is known as left shift operator. I know most of the people are not C language fans here, but this was like introduced in C, and like when we were kids and we learned these operators long back. This is called the left shift operator, right? So we are going to perform this on Y. So the Y currently is, let's say here, we're going to perform the left shift operator, okay, on Y. And let's say 1 2 3 4 5 6 7 8. Y is currently 3. And if you perform the left shift operator, let's say on carry, oh sorry, this will be on carry, my bad. So this is carry, so we have to save the value in Y, and if we perform the operation on carry, which is 2, sorry, so this is 2, and if we perform the left shift operator, this is gonna shift to here. So if we perform the left shift operation, it's gonna convert to 0 0 0 0, and this will shift here and this will become, I guess you got this one right. So this is gonna shift like 1 on the left from here to here, right? And this is the binary for 4, right? So y is currently 4, and I'm gonna save the value, right? And then we have to return x. Now x is currently like x and like x or y. Like if you perform like additionally, like this is just to return x, but if you perform like we have y as 4 and x as 1, even if we like print 4 XOR 1, it's gonna give you the result as 5. So here we, in this line, we, the code shifts the carry variable by 1 so that we are adding it to the x to give, the required sum. So this was, a pretty small problem, but to give you the idea of giving the time complexity into consideration. And like big companies uh, give you challenges regarding the code, that okay, for example, let's say if this code can be performed in zero point 0.5 seconds, can you bring it down to 0.25 seconds? Like what can we do? What's there for code optimizations? So these are the things which are used. Let me still try. I don't know if you're gonna get the result for this one. Say time, it's just like 1.31 milliseconds, and time for this one 1 point. So it's like wall time is like, you can see the difference, 1.31 milliseconds or like 870 like microseconds. So I know this is like a small thing, but I guess big companies care about like how the code performs, and you're gonna get this a lot during interviews, that okay, code optimizations, like how you're gonna improve this code, or how you gonna improve the readability of the code by these things, and these type of challenges come. So anyways, thank you so much, keep learning.